Welcome to Mr. Chalk's Revision Tips. In this video, we will look at
pressure in gases, pressure and changing pressure. So the particles in a solid simply vibrate around a fixed point. The particles in a liquid roll over each other. Particles in a gas, however, are moving very quickly and in random directions. The speeds of the particles in a gas can vary, but on average they will move quicker than they do in a liquid or a solid. Gas pressure is caused when gas particles hit the walls of the container that they are in. The more often the particles hit the walls, the faster they're moving. So when they do this, the higher the pressure will be. So this is why the pressure in a tyre or a balloon goes up when more air is pumped into it. So the figure to the side shows a filled balloon with helium gas. So describe the motion of the particles inside the balloon. Key things that we're talking about is that they're moving around at a range of speeds and moving around in many different directions. If a gas is heated, its particles move around more quickly. They hit the walls of the container harder and more often. This increases pressure. Sometimes the pressure gets so high that the container may burst. So this is why balloons and tyres burst if you blow them up too much. It's also why deodorant spray cans carry warning signs telling you not to leave them in the sunshine. If they get too hot, they may well explode. So there is also a relationship between pressure and temperature. If the pressure gauge is connected to a flask of air and the flask is heated, as shown on the graph, the pressure will increase as temperature increases. Boyle's law, or the pressure volume law, states that the volume of a given amount of gas held at constant temperature varies inversely with the applied force of pressure when the temperature and mass are constant. Another way to describe it is by saying that the products are constant. So when the pressure goes up, the volume goes down. So for a fixed mass of gas at constant temperature. So pressure times by volume gives us our constant. So pressure 1 times by volume 1 is always going to be the same as pressure 2 times by volume 2. So pressure 1 and volume 1 are the pressure of the volume before either a change. Pressure 2 and volume 2 are the pressure and volume after the change. So if we have a question that goes, a gas occupies a volume of 0.5 meters cubed and the pressure is 100 pascals, calculate the pressure exerted by the gas if it's compressed to 0.25 meters cubed and assume that the temperature stays the same. You would go and rearrange that equation so that the second pressure would be equal to the first pressure times the first volume divided by the second volume, which would give you a pressure of 200 pascals. If we look at this question to explain why the pressure in a gas increases as the gas is compressed, key things to talk about is that the volume of the gas decreases, so there are more frequent collisions of gas particles with the container's walls. So each particle collision with the wall causes a force, so greater force will be acting on the walls of the container.
Thanks for watching.